Hi guys, very good afternoon.
Hi, Chetna.
Yeah, hi Anirudh. After a long time.
Yeah. Actually, I skipped the AWS part because I
Okay.
was busy on Saturday, Sundays as well to work.
Yeah, okay. Got it.
Yeah.
Suddenly the class is crowded today. A lot of new
I
faces
saw
I'm
your
seeing.
documentation, right? So I just joined.
Yeah, some new faces also I'm seeing. I mean, some new names.
Yeah, I think there is another group of SRE. Probably they posted your link there as well.
Oh, okay. That is the
Yeah.
reason. Oh, okay. Okay, guys. Let's start Docker session today. Before, yeah, till now, yesterday we were discussing about AWS. We completed. Maybe let's wait for 2 more minutes. Few people are joining.
Sure.
Let's start. Uh, is my screen visible?
Yeah, it's visible.
Okay. Yeah. So let's start with the Docker today. So as I said yesterday, this is phase 2 of our journey. So till now we discussed all the basics required. This is what the accelerator of your career, Docker and Kubernetes, and then Terraform are the actual accelerators for your career, which will help you land in good package and good companies. So let's not delay much and we'll start. So before Docker, right? So what is happening and what is the issue facing? So first, let's discuss what is Docker, and after that, I will explain you what is the issue that Docker is going to solve, right? Any tool which is invented or which is created for the purpose of to solve some problem, right? Yeah, industry might be facing some problem, and any tool which was introduced might be solving that problem, right? And Docker is the most adopted tool in the industry. Industry-wide, this is the most adopted tool. So from the last decade, more than a decade, it came into in 2013, almost 16, 17 years back, right? And still, it is relevant till date. And why is it so took that much of importance in a software life cycle? And what is the problem it is solving? First of all, what is Docker? For people who are new to Docker, Docker is a containerization platform. Anyone waiting? Docker is a containerization platform or software. And using Docker, we can build, ship, run, and execute applications that are softwares as a containers. So this brings us to the question, first, what is containerization, first of all, right? I'm talking about Docker is a containerization platform or software. Using Docker, we can build, ship, and we can run applications. Run applications, application is nothing but a software, right? So run our software. Software as a containers. So first of all, what is containerization? So containerization in general terms, what is container in general day to day? If we talk about, if we not talk about the software, containerization is something, some bots where we pack something, right? Generally in shipping or something, shipping containers, big containers. You might have seen in cinemas or movies, right? Containers. This one. This is like one container, big container. In software term, when we are talking about Docker or when we are talking about any containerization tool, first of all, what is container means? Here also, it is packing. We are packing something and we are creating a container from it. We are packing something. What we need to pack? Generally, what we need to pack as a software developer or as a DevOps engineer, developers will write some code and we want to pack it. Why we want to pack it? So let me explain what is containerization. Containerization is a process of packing. Is a process of packaging what we want to pack. So packaging an application together with all the necessary required packages so that it can run on its own. So what we are packing, we are packaging, let's say code. We are packaging runtime. What is runtime? Like if you are running a Java application, we need Java runtime. If we want a Python, if you are the application is developed in Python, we need a Python application, Python runtime, Python installation, and also any dependency softwares. Any dependency softwares for this application to run, and code, runtime, dependency softwares, and also configuration files, something like that. Configuration file, configurations into one single lightweight unit, into one single lightweight unit called as a container. So containerization, just the same thing here. If you are parceling something, if you are sending something overseas, something from India to US, let's say you want to send something, what you will do, you will package something. You will keep whatever required into these things, and from India it will be transferred to some other countries, right? Same way here, the requirement is we want to pack everything that a code requires. Let's say I have written a code, developer has written a code in Java, then he needs Java runtime, JVM, right? Java machines, Java installations, JRE, Java runtime engine, JVM, JDK, these kind of tools. If this application requires JVM, JRE, or JDK, then this runtime will also be packed together with this code. And also any other dependency software, maybe like Tomcat or something other web servers we need. In that case, we will pack that one. And also the configurations which these code, runtime, and dependency softwares require. So those are configurations. So we will pack everything that a code is required into one single lightweight unit called a container. And to run all of this, we need some operating system. So in our servers, if you deploy directly, let's say previously we have seen, we have installed Nginx web server on our VMs, EC2 instance, right? Previously, we install apt install Nginx. Nginx is one application, right? To run this Nginx application, we need some operating system. So with code, runtime, dependency software, and configurations, along with the required operating system libraries also we will pack. because ultimately we need operating system to run the code. Without operating system, nothing will work, right? It is just a server. On top of the server, we need operating system, right? So we pack required operating system libraries, code, runtime, and also dependency software. This entire thing will combinedly called as a container. So why it is required? When everything is inside a container, there is no dependency, or there is no way that it will not work in one environment, it will not work in other environment, because uniquely it will work in any of the environment, whether it is developer environment or whether it is staging environment or prod environment. All the places we can expect the same behavior. That is our ultimate goal. So if it is working in dev environment, it should obviously work in the prod environment, because the same OS library, same code, same runtime, and the same everything. That is the required target for us. So before going to explain Docker, let me take some time. What is the previous traditional deployment style, and what is virtualized machine called VM, virtual machine, and then why containerization came into picture. So let me explain you before what is the problem with virtual machines, why industry has moved to containerization. So first, let's discuss about traditional deployment. So what is there in traditional deployment style way before 1990s around? What was happening? So first, we will be having something called bare metal system. This is the actual hardware which contains all the resources like CPU, memory, RAM, these kind of things, and also hard disk, storages, network devices attached, these kind of things. First, we will have this hardware, bare metal hardware. This is the actual hardware which contains CPU, memory, RAM. Memory and RAM both the same. And hard disk attached. So on top of this, we will be having something called operating system. Any operating system, whether it is Unix, Linux, Mac, or Windows. On top of this, we will be having softwares. After we get the system, what we will do, we will install the dependency softwares and libraries. Then on top of this, we will install our application. This is our application. So first, this was the traditional way of deploying previously in good olden days, right? Yeah. So what they were doing then? First, they will purchase this hardware. On top of it, they will install this operating system, which it can be Unix or Linux, and then we install the dependency softwares. Let's say if my application is on Java 11, it requires Java 11, then they will install Java 11 here, and any other libraries or required dependency software they install. On top of this, our application will run, and they will install our application. Let's say, what is the disadvantage of it, right? Let's say if I want to deploy another application here on the same operating system, on same hardware. Let's say this hardware has 32 CPU and 64 GB RAM. This hardware has 32 CPU and 64 GB RAM. Then let's say this application is only using 8 CPU and some amount of maybe 16 GB of RAM. Then other resources are wasting here. So let's say to utilize. Now it is underutilized. Maybe to utilize this hardware resources, maybe I thought to deploy one more application on this system. In that case, let's say if I want to deploy another application which is developed on Java 7, the requirement is it requires Java 7 as a dependency software. In that case, can I install Java 7 also here? Is that possible to deploy? Is it possible to install Java 7 and Java 11 on the both on a single machine? Both should be deployed on one machine. Even if you take your laptop, is it possible to install Java 7 and Java 11 or other versions of Java at the same time? So you cannot run an application, two applications which require different versions of a dependency software like this. So I cannot deploy Java 7 like this here. Maybe I can deploy some application which is running on Python maybe. And I'm taking some other example. Let's say I can deploy another application which is running on Python. So here, maybe I can run Python here. I can install Python as a dependency software. That is possible. I can install Python. That is fine, no issues for now. Because Java 11 can run independently and Python can run independently. But let's say what is the major problem here? If something happens from this application, which is on Java 11, if it corrupts something in the operating system, any application running might have, because we have directly deployed on the system itself, no isolation between operating system and our application. Our application is directly talking to the operating system, and operating system is also directly installing required things from the application. So our application is directly talking to the kernel, and maybe it is quite possible that our application can corrupt this operating system or any other softwares inside this system. Then because of this application, the other application which is deployed on this system will get affected, right? There will be a downtime for this application also, just because this application has created some trouble inside this system. So entire server has to go down, and also just because of this application, other application is also impacting. Maybe I am taking two examples. Maybe on this server, there are tens of application deployed like this, right? In that case, just because one application is causing some trouble in the system, other applications are directly seeing the impact. So major takeaways for this is, first one, we cannot install two softwares, two dependency version softwares, two software versions of the same kind, like Java 11 or Java 12. Second, if something happens in one application, it will directly impact the other application. These are the drawbacks. Will impact other applications, right? So this is in late 90s or around 1990s. At that time, this is called traditional deployment. This is the way of deployment. Just to avoid this, what we can do in the best case, we only deploy one application per server, even though it is underutilized. So for Python application, they will deploy another set of servers. On that, they will deploy Python. If another application, another server, even though the resource utilization is underutilized, they don't have another option to install, right? Just because one application is causing another problem to another application, it's not a good idea to deploy all the application in one server. So then the cost is also increasing because of this pattern. Later in 2003, around 2004, there is some concept called virtual machine. VM, what we are calling it. Yeah, sorry. Anyone asking something? Yeah. Virtualized deployment came in. First one is traditional deployment. Second one, in the late 1990s or early 2000s, there is something called virtualized deployment came into picture. So what happens in virtualized? Just to overcome some issues here, to overcome the issues we are facing, like we cannot install some same software, two versions of the same kind of software, and also some issues with other application is causing some issues to the one other application deployed on the same server. To overcome this, we have brought something called virtualized deployment. So same here also. First, there will be hardware like bare metal server. On top of this, we obviously require operating system. On top of this, there is something called hypervisor. This is also one software. So this is one software, hypervisor. Using this software, we can virtually divide this hardware resources, this bare metal resources, we can virtually divide into each VM, virtual machine. This is one virtual machine. This is one virtual machine. And like this, based on the resource size, we can increase the virtual machine. Let's say in the previous example, we have taken 32 CPU and 64 GB RAM. Same way, let's say this one I have divided using this hypervisor software. I can divide this hardware resources virtually, software-based separation, right? Isolation. So 16 CPU and 32 GB RAM, and one I can make it to 8 CPU and 16 GB RAM. Another I can take to 4 CPU only and 8 GB RAM. Like this, using virtual deployment, using virtualized system, virtualized machines, something called hypervisor software, what we can do, we can divide the underlying resources, underlying hardware resources into chunks, right? This is one chunk, this is one chunk, and this is one chunk. Based on this, we can divide into how many machines we want, like that. This entire box is one virtual machine. So each virtual machine, what it contains, it will run as a isolated system. This one box will work as a one system in the end. So just like previous, this entire thing is one system, right? The same way, this one box, this virtual box or virtual machine will act as a one server. This entire thing is a one virtual machine, VM. So this will act as a one server. So in this server, what we need, this is one machine, virtual machine. So in this machine, again, on top of this, we have to install operating system. On top of this, again, we have to install our dependency softwares. Dependency softwares like Java 11, Java 7, like that. So in the previous example, here we have taken Java 11 and our application is on Java 11. Same way, here I have installed Java 11. On top of this, I will install our application. This is our application. So what is the problem here we have solved? Using our hypervisor software, we have virtually we have isolated the software resources, hardware resources using the hypervisor software. And because of this, each machine will work as one system. Virtually, it will work as one server. So this is one server, this is one server, and this is one server. Ultimately, it is taking the resources from the underlying hardware resource only. So now this entire box, this entire virtual machine is one hardware system, one server. So now, even though it has 32 CPU, we have divided it into 16 CPU. And here we are maximizing our maximum, we are utilizing the hardware capabilities, hardware resource capabilities, right? We are not wasting our resources, right? This entire box is isolated from this server. This is one server and this is one server, and there is no dependency or any connection between this server. This server don't know this server exists. All they know is this server only knows the details about the hardware, underlying hardware. This server don't have any idea about the existing other virtual machines, right? Here we have achieved the isolation. This one, the second one which we are talking. So each one is separate from one another. So what is the advantage of it? Here I can deploy Java 11. In this server, I can deploy Java 7. If there is one application which requires Java 8, maybe, right? In that case, I can deploy our Java 7 based, Java 8 based application here. Ultimately, both will be using the underlying hardware resources, and there will be some guest OS here. Again, as this itself is a server, we need to install something called operating system again. So first, there is an operating system here also. This is the host operating system. This is the host operating system. This is guest operating system. For the naming purpose, this is guest operating system, as it is on top of the existing bare metal. So let's say if some other application we want, we can even deploy other Python based applications also, other Go language applications, any other language applications, right? Here, using this virtual machine, what we have achieved, we have resolved these two problems, right? We can install here. In this case, I cannot install Java 11 and Java 7 on the same system because entire thing is one system. So here, by virtualizing this system, we have divided the system into 3 chunks, and we can able to install. Each system will act like one server. So we can install Java 11 here, we can install Java 8, and we can install Python here. Underlying hardware is same, and we are here. The advantage is we can utilize the system resources most efficiently. And no issue with installing softwares, right? Dependency softwares we can install. Third, even this application, previously we have discussed the problem. If something happened in this server, in this application, the entire server has to go down because this application is causing some problem in the operating system kernel. That's why the other applications which are running here has to face the impact because of this software, right? Same here. If this application causes some trouble or some problem, where it can cause the problem? It can cause only the problem in this operating system, right? It cannot cause problem in the underlying resources. It only causes problem to this server. Entirely this server is isolated. Isolated servers from each other. This server is different, this server is different. So if this application causes any problem in this operating system, only this application will go down. The impact is limited to this application. It cannot impact the application which is running in this server. It cannot impact the application which is running in this server. So we have achieved the problem. Using this virtualized deployment, we have resolved the problems which we are facing with the traditional deployment, bare metal deployment style, right? Now, no impact between other applications, between the applications. So One application cannot create any impact, any slowdown in other application. Each one is different. Understood, guys?
Yes, Chenna.
Okay. Now let's go with containerized deployment. First, we are trying to understand what is the problem and how this containerization has solved the problem. Now, containerized deployment. Previously, we have seen traditional deployment, virtual deployment, and then containerized deployment. This virtual machine is nothing but, this box is nothing but the EC2 instance we are talking about. Let's say if our application is deployed in one EC2 server, another EC2 server will not have any impact, right? Just to give us a real-time example. This is one EC2 machine. This is one EC2 machine. So I can install Java 11 in one EC2, Java 8 in another EC2 machine. So even if your application caused some problem in EC2 server, that doesn't impact another servers in your account, because they may be using the same bare metal server, or maybe another bare metal servers. It has been virtualized based on that server. Again, in hypervisors, we have discussed when we are talking about, when we are discussing AWS, I have explained hypervisors are two types, where type 1 and type 2 are there. Type 1 doesn't require this operating system at all. This operating system we can remove if that is a type 1 hypervisor. I'm trying to explain again. There are two types of hypervisors, type 1 and type 2. Type 1 hypervisor, what it requires? It requires an operating system on top of your bare metal, and then on top of the operating system, we can install a hypervisor. That is type 2. Type 1 don't require this. In the case of AWS, we are talking about. Directly, we can remove this, and directly on the bare metal, we can install the hypervisor software like this. That is type 1. In case of AWS, they are using type 1. When I am installing some hypervisor in my laptop, that is type 2 hypervisor. If I go with installing virtual bots or something, Oracle VM virtual bots, if we are installing this, what it is doing? First, we have a laptop, that is a hardware resource. On top of this, I have Windows operating system. On top of it, I am installing this virtual box. What it is doing? It is virtually creating servers on my system, right? It is taking the resources of my system and virtually creating machines, VMs. That is called type 2 hypervisor. Type 1 generally used in the data centers, where they buy the bare metals, big bare metals like 512 CPU or 1000 CPU like that. On top of this, they directly install the hypervisor. On top of it, this hypervisor will create the virtual machines. Just the same way we have virtual bots in my machine, this Oracle VM virtual bots. This is type 2 hypervisor, which is an operating system based hypervisor. And type 1 is a hardware based hypervisor that is even more efficient, as we can tell. And what is the disadvantage of this before going to containerization? So first, traditional deployment, these are the two disadvantages. Second, we overcome those disadvantages using virtualized deployment. And again, what is the disadvantages of this one? This is heavyweight. How it became heavyweight? First, it requires guest host operating system. On top of this, we have another operating system. And each application requires its own operating system. Even though if we go with type 1 hypervisor, each virtual machine, each VM is requiring one operating system on its own, right? And operating system will not come without utilizing the underlying resources, right? Even if this operating system, let's say this virtual machine, this EC2 server has 16 CPU and 32 GB RAM. To run this operating system, again, it requires some amount of CPU and RAM, maybe 1 CPU or 2 GB of RAM. I'm taking the minimum. right? It is required 1 CPU and 1 GB RAM. Here also 1 CPU and 2 GB. Here also 1 CPU and 2 GB. In that case, we are wasting 3 CPUs and 6 GB of RAM on total of 3 virtual machines. If I consider the minimum requirement, right? For the operating system, it might take even more if you consider Windows operating system, right? In that case, unnecessary wastage of the resources just for the operating system itself. Even our application is not using that. Even before our application uses some CPU resources, the operating system, the server itself is utilizing. The server itself has the OS, separate OS, and it itself requires some amount of CPU and memory. That's how it is heavyweight, and we are wasting our resources on the guest operating systems again. Each EC2 instance requires its own operating system. Again, that is a wastage here. Our resources are wasted on guest operating system. That's why it's a heavyweight. It cannot be created in seconds, right? Again, it will take some time to spin up. In the case of EC2, it may take 3-4 minutes to spin up, maybe 2 minutes or 3 minutes. But generally, if we want to create a virtual machine in our on-premise data centers, it requires a lot of time to spin up. First, we have to raise the approval, then we have to create the virtual machine, then they have to provide the required network. On top of it, they have to give us the access. And this takes a lot of time consuming, and also resource wastage because of the operating system. That is one disadvantage. Even though it is able to fully isolate one server from another server. Resource wastage because of guest operating system. And this hypervisor software again requires some amount of CPU and memory if it is a type 2 hypervisor. This also requires this hypervisor to run. First, we have to install this hypervisor. This hypervisor also requires some amount of resources to run, either it is CPU, RAM, or any other resources. This also requires some CPU and memory. That's also some amount of our resources are wasted here, right? Okay. So these are the disadvantages of virtualized deployment. Let's move to containerized software, containerized deployment. So in early 2013, sometime around 2013, there is one company called Docker which came up with containerized software called Docker. Here, using containerization, we are taking the isolation to the next level, to one more step above the previously. There is isolation in the virtual machine level. Each virtual machine don't know each other. There is isolation, separation between two. Each server don't know other server, right? Here we are taking the isolation on the next level, one step above. How we are achieving this? Let's see how we can do containerized deployment. So as usual, we have our hardware. Bare metal hardware servers, or it can be a virtual machine also. This entire thing can be a virtual machine also. I will explain that. So hardware, on type of this operating system. You can consider this as your laptop also. You have hardware and you have operating system, right? Here, instead of hypervisor, we will install something called containerization software. That can be Docker, that can be Podman. There are different tools also. Let's say we have to install something called containerized software. This OS can be anything. So here what we are having, we have containerized software. On top of this, we install Docker in our system. On top of this, we create containers. Directly, this is a container. This is container 1, let's say, for example. Container 2. And then we can install one more application, as many as possible, right? Based on your CPU and memory resource capacity. If you have huge big server, you can install more containers like this. So what is this container? Ultimately, the end goal is we have to deploy our application seamlessly, right? And we have to utilize the hardware resources more efficiently. That is our goal. So here in this container, what will happen? We have everything what is required here only in this application. So here we have our software libraries like source code. We have our runtime. That can be Java, that can be Python, that can be any other thing, and any dependency software this application requires. Let's say in our case, if it is Python application, then we need Flask or something like that, right? Some dependency softwares. And any other configuration files. So first we will install all of these things, and on top of this, we will run our application. Here also the same thing. We will install the dependency software, libraries, and whatever required. On top of this, there will be some application. Here, no need of any isolation. Everything, each container is isolated from one another. No need of, even if this container, any issue happens in this container level, only this container faces the issue. We'll see the impact. The impact will not be spread across all the containers. If something happens in this container, in this application, any issue happen in this application, anything happen in this software, anything happen in this operating system, only this container will see the impact. This will go down, right? It will not serve the request. But other applications, there will be no impact, right? And also each container will have its own required operating system libraries. Here we are not keeping entire operating system here. We are just keeping the required operating system libraries. At the end, our operating system is a package of libraries, right? Different libraries we have. Let's say if we talk about ls command, cat command, network-based commands, file-based commands. So everything underlying is one library, or underlying is a binary, right? We only install the required binaries in this operating system. It is not a complete operating system, so it will be very lightweight. It is less than if we talk about some operating systems, it is even, let's talk about, there is some operating system called Alpine. In that case, the entire operating system libraries, to some extent, it will come in 40 MB or 30 MB also. But only minimal operating system will be present for the application to run. That is sufficient. Our application, whatever the software the application requires, only that much required operating system is present in this software. This is Alpine is also one kind of operating system, just like Ubuntu and Red Hat. This is also one lightweight operating system based on Linux only. So this is 40 MB, very lightweight, right? And at the end, we want our application and we want to maximize the utilization of our servers. We don't want any underutilization, we don't want, and we don't want any wastage from the host operating system. So in the traditional deployment, what we understood, we are underutilizing this capacity. Even though the bare metal has 32 CPU, just because there is some issue, we cannot deploy other applications here, right? We cannot deploy these applications. We can only run one application per server. So here, the problem is underutilized. Even though you have 32 CPU, you can use 8 CPU only. That is the reach of your application. But in the virtualized deployment, we are okay with the utilization. Here, the utilization is efficient because we are able to deploy multiple applications on the same underlying hardware. And we brought hardware isolation here also. Each one is a server. Each one is a different server. Like that. But what is the problem here? We are wasting our resources in the form of guest operating system. So that is how containerized deployment is solving the problem. What is the problem it is solving? Even though the hardware is same, even though operating system is same, just by installing this software, containerized software, this handles each container as a separate system of its own. This is one application system. This is one application system. To spin up this system, it takes very less time, very less than 1 minute. We can say in seconds, we can bring up this container. And this container will have everything that is required for the application to run. Previously, I have explained here what we are packaging into containers. We are packaging the required operating system libraries, the minimal libraries which are required for the application to run, and then the code, runtime, and dependency software configurations. So this container, each container has its own dependency softwares. Let's say if I am running Java application, only Java-based required software libraries and application will be installed here. And we will see in the next further session how that we can pack them on these kind of things. And let's say in case of Python, if the application is running on Python, let's say if I go with Alpine operating system, that comes less than 40 MB. Sometimes if we squeeze the operating system, if we remove the unnecessary things, it even comes with 12 MB or 15 MB also. 15 MB operating systems, very lightweight. But performance is same as other operating systems. It is ultimately, at the end, it is a Linux operating system only, right? On top of it, let's say we want Python runtime, and then maybe Flask frameworks, related softwares we want. On top of it, some configurations. And then our application code we will install here, our application. Entire thing is one set. This is one container. And this is and also one major issue it is solving is one second. Let's say just because it has everything as a package, it will work everywhere as same. What does that mean? Let's say if I install this system in one server, this container will work the same way. Even if I install this container in my local laptop, it will run the same way. And if the same way, it will work in another environment also. The same dev environment, the same prod environment, the same way it will work in the staging environment. Across environments, it will work the same way because it is not depending anything on the underlying operating system or underlying hardware. It is entirely dependent on itself. It is self-sufficient. That is what I am trying to say. It is self-sufficient. Why it is self-sufficient? It has everything what it requires. In this case, if I talk about virtual servers, virtual machines, maybe here, if we deploy our application, here it will work fine. But let's say this is our dev environment. But if I move it to the prod environment or pre-prod environment or maybe staging environment, maybe it will not work the same way it has deployed here, because there might be most of the times version mismatches, operating system kernel configuration changes, or we don't know many other changes which will come in the operating system level or in the server level, right? So most of the time it may not work the same way as it worked in one environment. In developer environment, it might work same. So people who might have worked with developers, you might understand, people always say, developers always use it to say, it is working fine in my system, only issue with the server. It is the usual quote they will say, it is working in my system. There is no issue with the developer code, right? But it is not working in one server. What is the issue here? The issue might be in the version mismatches, version conflicts, or any other dependency softwares we forgot to install in this machine, or any other kernel configuration settings that might have changed because of the patching activity, right? But here we are not depending anything on the operating system. We just have everything as a package, and this package, we are only creating this package and we know what is required here. So once it is running here, it will run everywhere. So what is the advantage of this? The major advantage: build once, run. Once you have the container, it will run the same way across any system, any operating system, or any other environment. That is the major advantage of Docker or any containerization of deployments. At the same time, we are resolving these issues, right? Heavyweight, it is lightweight. As I said, it is only 40 MB. It is not 2 GB or 3 GB operating systems. No, it is very lightweight. And it is resource wastage because of guest operating system in the case of virtual machines. But in this case, no guest operating system. Directly we just installing containerization software tool called Docker, and this also utilizes very minimal CPU and RAM. 1 GB, mostly 1 GB RAM is sufficient. Minimal case, I'm saying. If you go with a lot of containers, this also will take CPU resources, but not like a guest OS, guest operating system. Even it will run with one CPU also. Here, only 1 GB RAM and 1 CPU, but we can run as many applications as possible depending on the hardware resources. We are not wasting any of the resources here in the form of guest operating system. Only 40 MB, very lightweight, and each container can spin up in milliseconds of time also. Just running one command, this entire application will come up. And the most advantage is, once you build the container, once you build the image, Docker image, you can expect the behavior same across the environments. That is how Docker came into picture, and that is the issue what Docker is solving now. Understood, guys? I try to explain simple. Anything, any doubts, anything you miss?
Clear for me, Chala.
Yeah. Anyone in the class? Any doubts? Okay. Let's take 2 minute break, quick break, and we will be back by 15:03 or 15:05. We can continue.
Sure. Okay.
Yeah, guys, let's start. So we understood how the evolution of Docker and how the deployments changed over time from traditional deployment to virtual machine deployment to now Docker containerized deployment, right? So build one. This is the advantage of using containerized deployment. That is how the deployment has changed over time. And let's talk something about Docker now. So we understood the containerization part. So to achieve this containerization part, there is something called Docker. This is a tool which implements the containerization in the backend, which achieves containerization. So like, is this the only tool available in the industry? No, there are a lot of tools like Podman is there, Cryo is there, Containerd is there. There are different tools are there. So Docker is one of the first tool which came up with the containerization platform. Before Docker, there is no other tools. After Docker, these are the new tools which came in. Podman is the one containerization tool which is Red Hat owned. Like this. And Docker also underlying it will use Containerd only. Docker is like a top layer on top of Containerd. I will explain this at the time of Kubernetes. So underlying it is using Containerd only. And you can use Containerd directly. You can install Containerd just like Docker. So these are other tools which are available to implement your containerization deployment containerization platform, or these are other softwares, containerization softwares. And is Docker open source software? Yes, to some extent, yes. Docker is an open source software, and also it has enterprise versions also. For the companies who want enterprise level softwares, Docker provides enterprise level software also. There they will what they will give extra, they will provide the required support for the enterprises, for the organizations, along with they will provide private registries. I will explain what is registry in some time. So they will provide some access to the private registries to the organization. Those are the only things, but I don't think anyone will go with Docker enterprise version. We ourselves are using open source Docker. So that is mostly no one goes with Docker support. Not required. This is a easy to learn tool and easy to implement also. That is the most advantage of Docker. We can easily learn this tool. We can easily understand this tool, and implementation also is very simple. That is the best part of this one. And what is the benefits it is providing? What is the advantages of benefits of this Docker? Any other containerization tool like Podman, easily portable. What is portable? You can ship it very easily from one machine to other machine. You can copy it, you can scale it. It is scalable also. How it is scalable? So you can spin up. In this example, I'm saying, right? You can spin up this machine. This is one container. It contains our application and required softwares. You can spin up this machine in seconds. It won't even take 10 seconds, 20 seconds. It can spin up in 3-4 seconds also. That much speed it is. So if you want 100 such containers in your system, just a matter of seconds, right? Matter of seconds of time. So highly scalable. Even if you want to scale this to 100 containers, each container is like one server only at the end. It is serving your application. And start and stop is very quick. You can start the container quickly. You can stop the container quickly. Instead of virtual machine, where virtual machine is taking time, it is to start and stop also, it is very, very quick, like in seconds only most of the time. And cost saving. How it is cost saving? Because ultimately the underlying resources is same. It is not utilizing, you are not wasting your resources. Underlying resources you are not wasting in the form of just operating system or some other hypervisor software you have to buy and install. Not required. And containerization software itself is free. This is open source software. You are not spending money in everywhere, and you are not wasting your money in the form of resources also. So that's how it is very much cost saving also. And as I said, it is lightweight. Lightweight because at the end of the day, the container maximum, to some extent, you can build a container with 250 MB also. 250 MB, 300 MB size images you can build. That is one container. The virtual machine itself will take, let's say if you want to create one EC2 instance, in the backend it needs one storage, right? EBS storage. We have discussed that basic, we want at least 5 GB of storage disk to be attached so that the EC2 instance can boot the operating system. But here, for the container to come up, it doesn't require that storage also. It itself requires just the 100 MB, 200 MB of space is also sufficient for this application to run, entire application. So the operating system is lightweight, and because of our application and everything after installing our application in the container also, maximum it will go up to maybe 1 GB is the biggest size. It depends on your application again. So these are the advantages, and let's see Docker architecture now, how it is. And Docker is developed in Go language. And we don't need to learn Go language to run this Docker or to learn this Docker, but just one information. Now let's see Docker architecture. In Docker, there are 3 important major components: Docker client, Docker Daemon, and Docker Registry. These are the 3 major components in the entire Docker architecture. 3 components. Very easy to understand. No-brainer it is. And the scale of the issue it is solving, and the architecture, if you compare, this is very much easier. And when you compare it with Kubernetes, Docker architecture and Docker tool itself is very simple. So first, there is something called Docker client. Docker client. This is where you execute your commands. Docker CLI or Docker client. CLI is command line interface. Let's say if I open my WSL, give it some time to open. Yeah. If I type Docker PS, it is the command to list the containers in my system. Right? Right now there are 2 containers. These are Kubernetes containers. So Docker PS, this Docker command, whatever you are executing, this Docker, the word Docker, here is a CLI tool, command line interface. This is what I am talking about here. This is the client. And this is the system. This is the command line interface through which you will talk to the actual Docker daemon. Right? Docker daemon is the server which is running in your system. You can consider as server. Where is that? The same system only. If I see systemctl status, This is the actual system which is running. But to talk to this system, we have to execute something called Docker commands. This is the utility which is provided by Docker to talk to this underlying software which is running. This is the actual software which is running in the back end, right? If I see ps-ef with Docker, you see Docker D is running. Docker D is the daemon which is running in my system, right? And underlying, as I said, it will underlyingly use container D only. Docker is a layer on top of this container D. So container D you can directly install also, that is also fine. But for our topic, let's discuss about Docker. This is the Docker daemon running. This is one software. And to talk to this software which is installed on my system, we need some CLI utility, just like ls, mkdir. Those are also utilities, right? Underlying, it is talking to the operating system, some binary. Docker is also one binary, same like ls, mkdir, these kind of commands. So this Docker, using this Docker, we talk to this system. This is one daemon, one software. What will be there in this daemon? There will be images, there will be containers. We will explain each of these in the upcoming lectures. There will be networks, there will be volumes, like this. So using this utility, we will talk to this daemon in a form of commands. So there will be Docker build command, there will be Docker run command, there will be a simple Docker info command. This is the command line utility. They are calling it as Docker client or Docker CLI. Both are same. Using this, we talk to this daemon. This daemon is the actual software, Docker software, which is running in the backend, in the background of your system. That is where the actual work is done. Here we will have a lot of containers, a lot of images. Image is the actual package which we will create. This is the bundle. Image is the bundle which contains the required software, like dependency softwares, runtimes, application. These are all the things present in the image. Using this image, we will build the container. So these are all the details present in the daemon, and we will talk using daemon. We will talk to the daemon using Docker command, right? And there is one more thing called registry. There is something called registry. What is the duty of this one? This is just like a storage. This is just like a S3 storage or some other storage, Nexus storage, JFrog storage, artifact storage repositories. So what is the duty of this one? To store the build images. So here what I said, using Docker, we will build the image, right? We will package everything into one container. That package is called image. This image, we want to store it somewhere else, right? In my local system, if I see Docker images, these are the images present in my system. After I build the system, after I build the package, I want to store it somewhere. I can't store in my local system, right? Usually we will build the package, we will group the package, we will set everything in my container. Somewhere I want to store it. That is where this registry comes in. The default registry is hub.docker.com. You can see the website also. This is the registry where all the images will be stored. You can create one account here, free account. You can sign up and you can save your images also. Right now, if I search with Nginx, previously we are using Nginx to install directly in the machine, right? apt install Nginx, that command we are using. That Nginx also that Nginx itself was available in Docker image. If you see this, they are storing it here in the registry. This website is the registry. Underlying this is one storage server, right? And these are all the information they are giving about this. And we will see in the upcoming lectures what are all these and how are the configurations. What is this tags? By click on tags, you see a lot of versions here. Like that, there will be, as I'm talking, Alpine system, right? There is 1.31.3 version. What are all these tags? What is the use of things? And previously, when we are installing with latest. Here also there is something called latest version. This one. So we will see in the upcoming classes what are all these. But here, this registry is by default hub.docker.com. But if your organization has some other thing, some other registry, let's say Nexus artifact registry is there, JFrog can also be used. Or if we talk about AWS has ECR, Elastic Container Registry. Here we will store all our images here, all our packages here, like that. So first, using this, we will build the image using Daemon, and to store this build images, we will use registry. And there are some commands from Docker how we can store it into the registry. So this is the architecture. So Docker client, this is a command line interface through which the user send the instructions to the Docker daemon. That is the work of Docker client. And what is Docker daemon? Docker daemon execute some commands sent by the user. Commands it can be installing or pulling an image from the registry, or running a container, building a network, creating a network, or stopping a running container. That can be anything. So Docker daemon works based on these commands which you are using from the Docker CLI. And registry, this is a centralized repository maintained by Docker, that is hub.docker.com. And simply you can call Docker Hub. The registry contains various images that can be used. Also, the other users, just like Nginx, this is the image created by the Nginx organization itself. These are official images. Same way, we can also push the images, pull the images from here. Push the images to this hub. We can also pull the required images, whatever our application requires, like this. We can upload and download. Pull and push means upload and download the images. Understood? This is the architecture of Docker. If any doubts, please ask.
Chana, can you explain the Docker image concept again?
This one?
Docker, yeah.
This is like an overview. I will explain what is Docker image in depth in the upcoming sessions. Here we are explaining just the architecture of Docker. So you understand what is CLI, what is daemon, and what is registry. That is sufficient for today. But how to build the image, I will explain in the upcoming sessions. Or you want to ask anything about the image?
Can you explain registry, how we store it?
This is the registry only. If you see, this is hub.docker.com. This is the official website of Docker Hub. Here we can create one account and we can push our images. Let's say in our organization, our developers have written the code. We want to build that code into one image. That is where the image contains everything, our code and also our dependency softwares like Python, Java, or whatever, or Flask. If we talk about Python requires Flask framework, those dependency softwares, and also any other operating system as a base operating system. So that image, we want to store it somewhere. Let's say if we talk about GitHub, GitHub is a centralized repository to store our code, right? SCM repository, source code management tool, that is GitHub. Same way, as we store our code in GitHub, we want to store our images somewhere. That storing mechanism or storing server is called as registry. Here we will keep everything. This is Docker provided hub.docker.com. Let's say in our organization, if we talk about my organization is using Nexus. This is internally hosted. Some team will host and manage this Nexus, and we, as a DevOps engineer, we will push the images to this repository or registry. Same way, if we are using AWS has Elastic Container Registry. I will show this in the upcoming lectures when we are dealing with images. Container Registry. This also works same as Docker Hub. Here, this is owned by AWS. This is only for AWS who has account, who can push it, who can pull it from there. Like this registry. There are many other artifact repository tools. These are also tools. These are also softwares, right? Nexus is one software. JFrog is one software. ECR is the AWS service. Just the same way, Docker is providing some centralized repository registry to store your images. That is where you store Hub. That is where registry concept comes in.
Okay, okay.
How it helps actually this Nexus or ECR, these tools, how it helps?
This is an introduction class, right? There is still 7-8 more classes will be there on Docker itself. In the upcoming sessions, I will explain you how you actually push the image, these kind of things. Here I am trying to explain the architecture now. I will in-depth practically, I will show you in the upcoming sessions.
Okay, fine.
Yeah, Monica, you want to ask something?
Yeah, suppose if we do not push the image after building to the registry, in the local after our system restarts, will that image be lost or it will be saved within the Docker daemon?
Images will not be lost. Even if you restart the laptop also, no worries on that part. But understand, let's say on our day-to-day basis, what will happen, let's understand. Let me clear the confusion. So here, this is the GitHub repository, which our developers has written the code. As a DevOps engineer, what is our duty? To build the code, to build it into one package, right? This is one small package, let's say. This package, we are calling it as image. I will explain what is image in the upcoming sessions, what will go inside the image, right? Using this, we have to pull the code from here to your local laptop. So this is my laptop. As a organization laptop or personal laptop, whatever it may be. Our developers has put the code in GitHub. First, what we will do, we will clone the source code, right? On top of it, in our laptop, we will write something called Docker file. This is the file which contain all the instructions how to build this image. Docker file is something plain text file which contains the instructions to build the image, to package the image. Here we will write all the instructions like step 1, we want Alpine operating system. Step 2, copy the code. I'm explaining in basic English. I will tell you how it will happen. Step 3, let's say I want to install Nginx. I will say install Nginx. Step 4, let's say I want to start Nginx. 5, let's say we want to run our application, right? So let's assume our application is Java based. Install Java 6. This we are writing in the Docker file. Understood? First, I am saying I need operating system. Second, I am copying the code which is there in the GitHub, which has already cloned and present in my laptop. Copying, I am saying copy the code. Third, if Nginx is required, install Nginx, start Nginx. If Java is required, install Java. And then, as already we have copied the code, we can build the code, right? Some maven, mvn. This is the build command. Clean package, like that. And then we have to start. How Java application is started, java-jar and then jar name, like app.jar. These are the commands we will write in the Docker file. Using this Docker file, this image will be built. But this is in my local laptop. This is my laptop. We are doing in my laptop, I mean company's laptop. I have written the Docker file. I have built the image. But understand where you are running the image, where you want to run our application. Somewhere in the servers, right? Not in your local laptop. The application should be deployed in the servers, company server. So you build the application in your laptop, but your laptop is not where you install your application. So what we are doing, we are pushing this build image into some registry, that centralized repository of the organization. That can be Docker Hub, that can be ECR, that can be Nexus, that can be anything. We just need to push the image which we have built in my local laptop, to some centralized storage server. That is, they are calling it as registry. After this, we want to deploy our application in some servers. Like this is one server, this is one server, and this is one server. Here, we want to pull the image from here. Here, our image is there now, because we have pushed the image. We have uploaded the image from my local laptop to here. Now it is available for everyone in the company, in the organization. Everyone who has access to this registry can see the image is available. Now, as a DevOps engineer, as an SRE, we have to install this application. Where we have to install? Some servers. So we will pull the image from here to here, to the required server, to all the servers where the image is required. This is just a package. This is just the package. Just pulling the package will not do anything. Again, out of the image, we have to create a container. This is the actual container, the application which will be running. So just by keeping the image in my laptop, will that make any sense? Right? The application should not be installed in the laptop. For testing purpose, that is fine. But ultimately, it has to be deployed in some servers at the end. So to make it persistent, to make all the users available, every user, every other person, every DevOps engineer or every developer to see the image, we have to keep it in a centralized repository. That repository is called registry. Just like GitHub, even though 5 developers are developing or 2 developers are developing, the code should be kept somewhere for accessible for everyone, right? That is where GitHub concept came in. The code should be available for every developer, accessible by every developer. Here, in the case, he is the developer. There are 3 developers developing the code. So each one want to access the code. That is where this repository, that is where GitHub concept came in, to keep the code centralized. This is SCM repository, source code management tool. Same way, to keep the images in a centralized repository so that every user can access this image. So for everyone to access the image and also for the servers to download this image, I cannot download this image from my local laptop. I have to keep it somewhere else for every other user to download or upload. That is where registry is there. That registry can be any other. Docker Hub is there. As I explained, ECR is there, and Nexus, JFrog. These are the examples.
Role of Daemon in this whole process.
Sorry.
What is the role of Daemon in the process?
Daemon.
Where Daemon comes into picture.
Daemon is everywhere. Daemon should be in my local laptop. Let's say if I run Docker build, where Docker build has to go? Docker build command has to talk with the Docker software. Docker software is the daemon, actual daemon, right?
Like
Docker
kernel
software.
Linux.
Sorry.
Just like kernel in Linux.
Just like any other software, ls command, mkdir command, those commands are binaries at the end. So Docker command is a binary, but at the end it has to talk to something, right, to execute that binary. That is where this Docker software is coming. But Docker software by default, if you install, in the next session I will explain how to install Docker. Docker software contains both Docker CLI and the daemon. Both will be installed. You don't need to separate installation for daemon and CLI. So in this case, if I am building the image, if I just run Docker build, If there is no Docker software installed, then build will not work. This command will not work, right? So here also daemon should be there. In my laptop, Docker software should be installed. Here in the server, here package is built, but software application should run. Here in this example, I told, first on top of the operating system, containerized software like Docker should be installed to run this container. So in the server also, Docker should be there. Docker should be there. In the server also, Docker should be there. In all the servers, it should be present. This is the Docker daemon. Like this. So you build the image, you run anywhere. Like this. Here you are building the image in my local laptop, but the application is running everywhere as is in all the servers. Here I am showing 3 as an example, 3 servers, but it can be 20 servers or 30 servers also. That is, daemon is just like a Docker software. It will be running in the background like this. If you see systemctl status Docker. Any other doubts, guys?
Nothing, Chenna, from my side.
Okay. So what is the Docker flow now? If you see this example, Docker flow. This is the exact flow, what happens. So I'm writing down into steps for easy understanding. First, image, we will first developers write the code. That is not our part. So we are discussing about our part. So first we will write the Docker file, which contains the instructions to build the image, which contains the instructions to package, right? How to package, what should go inside the package, right? Then this Docker file, the output is image. The output of this Docker file, if you execute the Docker file, image will be built. Image contains, the image is the actual package we are talking about. Third, we will push this to the registry. That registry can be, again, this registry, there are 2 types. There are public registries and private registries. What is public, what is private? If you push it to the Docker Hub, this is public, right? I haven't built this image. Someone built this image and I can able to download this image, right? If I click on this one, these are publicly available for everyone. And I can see a lot of details about this image, whatever instructions they have executed. Like if you see, these are the copy instruction. We will talk about all of these things in upcoming sessions. You can see a lot of details about this image. And also, they will provide the command to pull here, if you see. And if I execute this, Docker pull nginx :latest. If you don't use latest also, that is fine. Ultimately, what is happening here? This Docker CLI is talking to the Docker daemon, and then it is talking to the registry to download the image. Like that. This image is downloaded. Now, if I go with Docker images, this is the command to see the list the images, list the packages. So this one is pulled just now. What is this? 2 weeks ago, this image was built 2 weeks ago. Like that. Just because this repository is public, I am able to download it. But in our organization, the developer's written code should not be public, right? It is our organization's data. It should not be present outside. So we will keep in private repository. So normal public cannot pull and push the image. Only it should be present in the organization level. So I will explain how to create a private repositories, how to keep it private and how to keep it public in the upcoming sessions. And if I talk about the steps, then push the image to the registry and pull it to create a container in the servers, actual servers where you want to serve the application. It can be developer environment or dev environment or staging or testing, prod, or anywhere. Any environment you can pull. This is the Docker actual workflow. From Docker file, we will build the image using and we will push the image to the registry. And whenever we require, maybe we build the image today, but maybe we don't want to deploy it today. After 1 month, we can pull the image which is available in the central repository, pull the image to the container. Pulling means downloading the image, right? And we will build a container out of it. We will run a container out of it. And this image contains whatever is required: operating system libraries, software, and application, like that. Okay. One thing. Okay. Let me log into the AWS and I will show you how to install. Already in my local it is installed. I will log into one server and show you how to install. You can take any operating system. For now, I am taking Ubuntu. Even with the basic AMI, like T3 Micro, that is also sufficient. Just because Docker is very lightweight, even 2 CPU and 1 GB memory also sufficient. I'm taking 1 key. Any server you can create. It is having 8 GB of attached disk. That is also fine. I'm shifting to the root user. So coming to the installation part, Docker can be installed using 2 ways. Either convenience script you can use, or you can use the package manager, just like apt install docker.io. You can install this way. This is the easiest way you can install. Using this, both Docker Daemon and also Docker CLI commands will also be installed. Or another way, another easiest way is there is something called Docker convenience script is there, provided by Docker itself. If I go here, install Docker. Again, here based on the let's say based on your operating system, whether it is Debian or RHEL distributions, you can install this. But if I go down, if you don't know anything about your operating system also, they are providing one command, just installing, but that command will check what distribution your operating system is, and it will detect, and based on that, it will install also. So here also they are suggesting install using apt repository, just update, and you don't need all of these also, just docker.io is sufficient. apt install docker.io is also sufficient. Like this. And if you want to directly download the package like Debian packages like this, you can also download this, and they are saying another way to install. But the easiest way is convenience script. So if I go here, they are providing two scripts, two commands. Just executing this command is sufficient. So let me copy this. I'm installing this way. This is the best way to go with, because using this I will show you. So here I am getting the script into a file called get.sh. /l, yeah, bring get.sh. If you see, they have written a shell script which contains all the commands to install the script or install the Docker software. Here it is only downloading the latest software. It is only installing the required stable versions. We don't need to worry about that. And also based on the shell script they have provided, it will detect which distribution of Linux you are using, and based on that it will install. So we just need to provide executable permission for this, and we can just run this shell script. So using this command, I have downloaded the shell script, and now I am giving the executable permissions +X, and now I am running this one. This will by default install. Let me show you. Right now I don't have any Docker. Command Docker not found, right? Not there. So let me proceed installing. Get Docker. It will take 2-3 minutes to install. It will identify the software, download the required software, and install automatically. The same script will work in all of your servers, whether it is Amazon Linux, whether it is Ubuntu, or whether it is Red Hat. Red Hat don't support Docker, I think. All other software it will. Okay. Now it is installed. Let's see. Docker PS. Previously, command not found. Now it is showing some details, right? Now see systemctl status. Now it is active and running. Just by executing this shell script, it is able to install everything. Now here also I can pull the images. Docker pull nginx. If you don't give latest, it will take the latest tag only. Even if you remove this Docker pull nginx, it is by default attaching the latest tag, and it is pulling the image. If you see Docker images, one image is present. The size of the image is 241 MB. Like this. From the registry only it is pulling. How it is pulling? By default, Docker will pull from hub.docker.com. So we don't need to provide any credentials to pull image from public repository. But if you want to pull it from private repository, we have to provide. We have to use Docker login and give our username and password. Using that only we can pull from the private registries. So now image is present, but the application is not running. If I open the security context, so this is my command. If I go, this is my server. In the security, there is only 22 port open, and then it's worked on 80. So let me open 80 now. Edit inbound rules. So this is the actual server, and if I take the public IP, just the image is present doesn't mean the application is running, right? Nginx also one application. Here in my local system, if I use systemctl status Nginx is not running. If I install Nginx here, right, I can access using localhost 80. But no Nginx is running. Even if you check netstat-tnlp to see any application running, only 53 some other applications are running, not Nginx. Here also in the server, I can check netstat-tnlp to check what are the applications running. Netstat is not there, we can use. If you see some other application, SSD is running. To log into this system, SSH process is running. Some other processes are running. These are system related, right? But not our application is running. We have pulled the image. This is a package, but this having this package itself doesn't make our application. We have to make it install using something called container. So there is one command called .run -d and name whatever you want, you can give. One name Nginx and image name. Let's say -b port. This is called port binding. I will explain all of this in the upcoming sessions. Now this is running. Check with Docker PS. This is the container which we have created right now. This is the actual application installation. This is installed now. Now let's see, go to the browser. Now automatically it is resolved. How much time it took for the application to come up? If I executed it, I can execute less than 1 minute of time, right? That is the speed of Docker installations. And how it is that much speed and how it is capable of installing because of this package. This package contains everything required for the server, for the application to run. Here also I am not running as a daemon, Nginx daemon. Nginx is not running as a system daemon, right? If you see, there is no Nginx system status. It is running as a container. And if I see now ss-tnlp, now you can see something with 80 port. What is running on 80? Some Docker proxy is running. What is Docker proxy? At the back end, Docker is running in a Docker container. That is the meaning of here. It is saying some Docker container is running on 80 port. That is why we are able to see in the browser. Nginx is also one application. We have installed that application, and using that we can able to see the UI of it. So this is the installation part of Docker. And using this, so Docker info, you can get the information about the Docker, whatever we have installed. This is the, it will give detailed information about your Docker running inside your system. You just want the Docker version, you can execute Docker version. Docker ---- version also works. If you want just to see the basic details, what is the version? This is the version of Docker we have installed right now. And a lot of details are there inside this And by the time you are running, this Docker file also will use some directory in the backend, right? What is the directory? Where lib Docker. This is the home of Docker. Here it is where all the details will be stored. Where lib Docker. This is the working directory of your Docker file. Docker. Everything Docker will only see whatever is there inside this. How it is seen when we see Docker PS. How it is listing the containers, all the list of containers. By seeing what is there inside its containers folder. There is some container folder. Inside this, it will store the details in this format. This is one folder. Inside this, there will be other details. Like this, there will be some other details. Host name, mounts, resolved. These are other configuration files. And same way, we have something called images folder also. Here, we cannot understand what it is storing internally. Internally, that Docker manages whatever is there inside varlib Docker. So everything Docker will see, whatever command you are typing, everything Docker will see in this directory. It will get the details from this directory, like that. This is the working directory, varlib Docker. If I say Docker image, it is coming from this folder only. This is the folder. Like that. How much storage it is taking? Very minimal, 165 MB right now. Just because we don't have any other images, only Nginx, and Nginx container is running, and Docker default configurations are there here. Understood, guys? Any doubts till now? Till now, we have seen Docker installations, Docker architecture, and Docker flow, and also the evolution of Docker over time, why Docker came into picture, what is the advantages and disadvantages of other type of deployments. And I have shown you a simple demo of using Nginx, and installation part we have covered. In the upcoming sessions, we will be next session, I will show you all the CLI commands and how we can, what are the CLI commands available with Docker. And then we will slowly build Docker files. We will write our own Docker file, and then we will deploy a 3-tier application. And at the end, I will show you what is Docker Compose and this kind of thing. I have already given the syllabus to you. That's how we follow. That's it for today, guys. Any doubts you can ask me.
Yeah, nothing, Chinna. So we are going to covering Docker volume and networks as well, right?
Yeah. I think I have mentioned the same in.
Yeah.
In the syllabus I have given, no? Have I missed that?
No, Chinna, it is there.
It is
Okay.
there, I think. Yeah.
Yeah, Docker volumes, Docker networks, and also Docker Compose, how to write a Docker Compose. We will discuss all these things.
Sure.
Yeah, thank you, guys. Thank you so much.
Thank you, Chinna.
Thank you.
Thank you. Bye, guys.
Thank you.
Thank you, Chinna.